So this is the sum and the difference identity for sine. So let me kind of explain this notation a little bit, because this is actually two formulas in one. When we rewrite this, if we rewrite our angle measure as a sum of two angle measures, so like x plus y, then we're going to use the plus symbol in the other side of the equation, because that's on top, okay? So basically, like, the two top symbols are going to match up with each other, and the two bottom symbols will match up with each other. So this is really two identities that I'm writing at once, okay? You'll see how that plays out when we do some examples. So that's the sine one. We got one for cosine and for tangent. Cosine of x plus or minus y will be cosine x times cosine y minus plus sine x times sine y. So notice how I wrote this symbol a little differently. It's supposed to be an x. And what that means is that if you have cosine of like x plus y, which symbol will you use here? Minus. So like basically you just match up the top symbols and the bottom symbols. All right. This way we don't have to write 6 separate statements. We're just going to write 3. Yes, sir?
Could you go over that one more time, how you find out the positive?
Right. So this will make more sense when we actually get into some examples. But if you use the plus here, then you'll use the minus here. Basically, if you use the symbol on top, you'll use the symbol on top in both cases. So like for the sine, these two symbols should be the same. For cosine, they should be opposites. You'll see that? Okay. Now for tangent, tangent's a little bit more involved here. And again, you do not have to memorize these. I'm going to keep saying that, so you don't worry about that. The other ones that we learned last time, you do have to memorize. The Pythagorean identities, the quotient, the reciprocal, but not these. Tangent x plus or minus tangent y, that's going to be the numerator of this big old fraction, over 1 minus plus tangent x times tangent y. So these are looking pretty complicated, but really what's going to end up happening is we're just going to plug a bunch of numbers in here, and then you'll use your unit circle to evaluate most of these. Okay, so these are your 6 sum and difference identities. Once again, you do not have to memorize these. These will be given to you. You just got to know how to use them. So like we talked up on the board, I'm going to show you a couple of examples of how we could actually use this. Okay. Really our goal here is to be able to evaluate trig values of certain angle measures that are not those common ones around the unit circle. So let's just dive into the examples here. Let's say we want to evaluate sine of 75 degrees. Now, if you haven't had a calculator, you just type it in and get a decimal equivalent, but I'm not really interested in a rounded version of what this equals. I want to know exactly what it equals. Okay? It'll be irrational, so they're not going to be able to write it, as a decimal if you write it exactly. So, big problem here, 75 is not on the unit circle, so this is not going to be like just as easy as, oh, you go around the unit circle, pick out your y value. Okay, we can't do that here. But what we can do is we can rewrite 75 as a sum or difference of two other angle measures. So I already asked it once when we're talking up at the board, but let me ask it again. Can you think of, go around your unit circle, looking at degrees, are there two angle measures whose sum is 75? 45 and 30, right? So I can rewrite this as sine of 45 degrees plus 30 degrees. This is not a unique way to write this. You could potentially write this as a difference. You could do something like, I don't know, 135 minus, is that going to work? 135 minus 60 would work. Both of those are on the unit circle. So there you have a couple of options on how you could write that. But basically, once you figure out how to break down this number, now we're just going to start plugging stuff into the formula. So is this a sum or a difference? Sum. So when I look at this formula, I'm going to go with the plus here. That's how I wrote this, right? So in my formula right here, and I'm not going to do plus or minus, you have to pick one. So you pick the one that it sort of matches up with. So I'm going to write a plus here. Now in this case, what's my x and what's my y? Well, what's my x? Yeah, 45, that's my x, and what's my y? It's 30, right? So when you start plugging stuff in, that's where those numbers are going to go. So this will equal sine of 45 times, I'm just following along with this formula up here, sine of 45 times cosine of 30 plus cosine of 45 times sine of 30. Now, each of these are things that you can use your unit circle to evaluate, right? Like, what is sine of 45 degrees? Root 2 over 2. And what is cosine of 30 degrees? Root 3 over 2. What is cosine of 45? Move this up a little bit. Yeah, it's root 2 over 2. And what is sine of 30? So have your unit circle ready for these problems, for sure, because we're going to keep referring back to these. So what is it? What's sine of 30? 1/2. Okay, so we're almost done here. Now it's just a matter of just sort of combining these fractions into one big fraction. So we're going to start by just multiplying these together, and then we should have a common denominator, so that shouldn't be an issue. And then add them together. So root 2, so I multiply these fractions. You multiply fractions just straight across. So root 2 times root 3 is root 6. 2 times 2 is 4. So root 6 over 4 plus root 2 times 1 is root 2. And 2 times 2 is 4. Now I need to add the fractions. Luckily, we've got a common denominator, so we don't need to worry about that. So just add the numerators. Now these are not like terms, so I can't combine them even. So my answer is just root 6 plus root 2 all over 4. And that's what sine of 75 equals. Yes, sir?
Is that as far as we have to simplify
Yep.
it on the test?
That's as far as you can simplify it. You can't really go any further than that. Yeah. Any questions about that example? All right, so let's do another one. Let's do cosine of 11 pi over 12. Okay. So you want, there's a couple of ways you can get there, and I don't want to like give anything away. So I want you to really think about this. Like, look around your unit circle. You've got like pi over 6, pi over 4, pi over 3, pi over 2, all those common angle measures. And you've got to come up with a combination of two of them that either add up to 11 pi over 12 or that you could subtract to get 11 pi over 12. So I'm going to give you, a minute or two to try to figure that out, okay? Just pick two, add them together, see what you get. And that could be a good first step. Let's see who can come up with something that'll work out. So yeah, we can rewrite this as cosine of, let's see, I'll just pick one of those. We came up with two answers. So let's say pi over 4 plus 2 pi over 3. And you could use the other one as well. It does not matter. All right, so look back at your formula. All right, I have it on the previous page here. we're dealing with cosine, so, and we found a sum that adds up to 11 pi over 12, so we're going to be using the sum identity rather than the difference one. And so, which symbol should I use here? Minus, right? Because the two top ones are what you're going to kind of match up here. So just to make a note, here's my x, here's my y. When you're, it might not be a bad idea just to note that so you don't get mixed up when you're plugging things in. So yeah, we've got cosine x, so that'd be cosine of pi over 4 times cosine of 2 pi over 3 minus, so remember with cosine that sign is sort of reversed. So we got sine of pi over 4 times sine of 2 pi over 3. And from here it's just like a bunch of unit circle problems. So you're definitely going to want that unit circle like ready to go. All right, what is cosine of pi over 4? So that's root 2 over 2. Cosine of 2 pi over 3 is negative 1/2, yeah. Sine of pi over 4, root 2 over 2. And sine of 2 pi over 3, root 3 over 2, yeah. All right, y'all following along okay? Okay, so now we need to multiply. So when you multiply fractions, you just multiply straight across. We'll get negative root 2 over 4 minus root 2 times root 3 would be root 6 over 4. So once I combine those, I get negative root 2 minus root 6 all over 4. And that's the value of cosine of 11 pi over 12. All right, number 3. We'll do one of the tangent ones. We'll say tangent of 15 degrees. All right, so we're in degrees here. Go around the unit circle, and can you find two angle measures whose sum or whose difference is 15? 45 minus 30, yeah, that'll work. So that's 45 minus 30. And in this case, 45 is your x, 30 is your y. So we're just gonna start plugging things into the formula here. We've got, I'll just write this as a big old fraction, tangent of 45 minus tangent of 30 over 1 plus tangent of 45 times tangent of 30. So there's 4 instances of trig values that I'm going to find around the unit circle. Tangent of 45 is what? 1. Okay. Tangent of 30 is 1 over root 3. Now you could rationalize that. I don't really care if you do or not, but that's fine. Divided by 1 plus tangent of 45. We already calculated that. That's 1. Times tangent of 30, that's 1 over root 3. So I want to clean this up a little bit. I don't have to do a ton here, but what I want to do is really just get rid of this times 1, right? Because when you multiply by 1, it doesn't really do anything. So I have 1 minus 1 over root 3 over 1 plus 1 over root 3. And that answer is just fine. Okay, you could rationalize this and rewrite this as like root 3 over 3. You could find a common denominator. There's a lot of ways where you could kind of go further with this. You don't need to, though. This is good enough. All right, so last problem. This one's going to be just a little bit more involved, but there's going to be some problems like this in your homework. So in this case, what I'm going to say is I'm going to give you some trig values. So given that sine of alpha is 4/5, so alpha is just, you know, Greek letter, it's just a variable, it's an angle measure. Sine of alpha is 4/5. Sine of beta is 12/13. What is this starting to look like? It's kind of looking like a triangle problem, you know. Also, alpha is in quadrant 1, and beta is in quadrant 2. Very important. So I really haven't asked a question yet, have I? So let's find tangent of alpha plus beta. Okay. That's sort of our goal here. Now, I can sort of set this up, right? Like I can say, all right, well, I know the formula for tangent of alpha plus beta, or if I don't know it, I can look it up, right? So this is like my x and my y. And I'm just going to basically write the formula, right? It's going to be tangent of alpha plus tangent of beta over 1, not plus, almost messed that one up, minus tangent of alpha times tangent of beta. The problem here is we don't have any of those values. We don't know what the angle measures are, and we don't know what tangent alpha, tangent beta are yet. But what we can do is use this information to not necessarily find the angle measure itself, but to find the value of tangent alpha and tangent beta. So what we need to do is draw a diagram for each of these angle measures to help us figure out what the tangent values are. So let's draw a diagram. Draw two diagrams, one for alpha, one for beta. All right, so for alpha, alpha's in quadrant 1. So I'm going to draw a little triangle here. So here's alpha. What do we know about alpha? Well, we know that sine alpha is 4/5. So what is the SOHCAHTOA ratio for sine? Opposite over hypotenuse, right? So this is going to be 4, and this is going to be 5. Tangent of alpha is opposite over adjacent. So how would we find this missing side? Pythagorean theorem, right? And actually this is going to end up being a Pythagorean triple. What is this extra side going to be? Or this adjacent side? Yeah, 3. Yeah, 3, 4. It's a 3, 4, 5 triangle. So what is tangent of alpha then? 4/3. Yeah. So we figured out tangent of alpha without even knowing what alpha is. Now let's do the same thing for beta. Beta's in quadrant 2. And we know that sine of beta is 12/13. We can use Pythagorean theorem again to find this missing side. This is going to be another Pythagorean triple. It's a 5, 12, 13 triple. So I'll save you that arithmetic. But what do we have to know about, like, since this is in quadrant 2, yeah, it's going to be negative. So this should be -5. So what's tangent of beta? Negative, well, yeah, -12/5. So what we have now are the values of both tangent alpha, tangent beta. Well, we don't need to know alpha and beta. Now we're just going to go back to our formula up here and just start plugging stuff in, right? So let's take this formula and say, okay, well, what's tangent of alpha? Tangent of alpha is 4/3. So I've got 4/3 plus tangent of beta, which is -12/5. So I'm actually going to, instead of writing plus a negative, I'm just going to write -12/5, all divided by 1 minus 4/3 times negative 12/5. Now, there's no square roots in here. I want us to try to simplify this as much as we can. Okay, so just be prepared to start finding common denominators and all that stuff. So what you want to do is sort of simplify the numerator and the denominator separately, and then you'll do one last step where you actually do the division of the fractions. What's the common denominator for the numerator? Like, just looking at the numerator here, 15, right? So this will be 20/15 minus 36/15. And the only thing I'm going to do on the denominator for my first step is actually multiply these together. 4 times negative 12, 3 times 5, and I'll get 1 minus, or no, actually it's going to be plus because it's a negative times a negative, so plus 48/15. Now, what would be a smart way to rewrite the 1 here? Yeah, 15/15. And what's kind of nice here is because every single term here has a denominator of 15, we could just multiply 15/15 and cancel out all those denominators. So this will really just be 20 minus 36 over 15 plus 48. And for lack of time, I'll just tell you what that equals. Negative 16/63. Yep, there you go. All right, so.
Hey y'all, let's work out some of these practice problems. Now before we get started with this, what I would recommend you do is make a list, like I've done over here, of your common angle measures, or at least have your unit circle out and ready to look at. It'll just make some of these problems a lot more convenient if you have like a list of choices to pick from when you're trying to find like two angles that add or subtract to give you 105, for instance. Sometimes it's easier just to have a list to go based off of. And especially when we get to the radians part, one thing I might suggest is to, when you make this list, find a common denominator like 12 and rewrite all the radians in terms of 12. A lot of times these problems are going to have radians in terms of pi over 12, and it'll be a lot easier to sort of pick out which ones you need to add or subtract to get whatever angle measure you're looking for. So it's good to have this on hand as just like a little cheat sheet almost, and I've also written these sum and difference formulas down here so that I can reference them easily. So let's jump into number 1. We're trying to evaluate cosine of 105, and one of the things you want to think about is like, well, 105 degrees is not one of those common angles on the unit circle, and this is where the sum and difference formulas come in handy because they give us a way to evaluate something like this. So what we're looking for on this list are two angle measures that either add or subtract to 105 degrees, so we can split this up and evaluate this a little easier. So you will likely be able to find more than one combination that does this, especially if, one you could probably find using addition, one subtraction. For example, like 60 plus 45 is 105. You could also do like 135 minus 30, right? And so whether or not you do that addition or subtraction, you'll use either the the addition formula or subtraction formula. Your final answer may look a little different depending on sort of what combination you go with, but they should evaluate to be the same number. And what I mean by that is like if you get your final answer and there's a bunch of square roots and stuff inside there, if you throw all that in a calculator, whether or not you do the plus or the minus one, they should be equivalent, okay? And that's actually one way you can sort of check your answer. I think it's kind of tedious to be able to work each problem twice, but if you really want to make sure you got it right, I would do it both ways and see if you get the same thing. Again, your answer will look different because of all the square roots and stuff, that you'll have this irrational number, but if you evaluate those irrational numbers, they should be the same, should give you the same number. But anyway, so let's just start with one of these. Let's go ahead. I'm going to go with 60 plus 45. So so you're looking for two angle measures on your unit circle. So, like, let me bring back this list. 2 angle measures on this list that either add or subtract to 105. And one of the combinations that I was talking about earlier was the 60 plus 45. So we can rewrite this as cosine of 60 plus 45. And when we do that, when we pick 2 angle measures that we can evaluate cosine of and sine of, we can use this formula down here. Now, just to reiterate what I talked about in the notes, you'll notice like the sine formula has this plus minus, and the cosine formula has plus minus minus plus. So what's going on there? Well, this is just a more efficient way of writing 2 equations. Really, like for the sine equation, sum and difference, like this is both the sum and the difference equations sort of put together. And so when you're looking at whether or not these should be plus or minus, you're going to match up like the top symbol with the top symbol, the bottom symbol with the bottom symbol. So for instance, if you're doing sine of a plus b, this should be plus. If you're doing a minus b, this should be minus. For cosine, it's backwards. You're still matching the top symbol with the top symbol, but notice here the top symbol's plus, but here the top symbol's minus. So if you're going to do like 60 plus 45, when I go to use this formula, 60 plus 45, I'm going to make sure to do a minus in between here. So I'm going to use this formula to expand this out. So just to kind of remind us, cosine of a plus b will equal cosine of a times cosine of b minus plus sine a sine b. You don't have to write this out every time. Once you kind of get a feel for these formulas, it's not really worth it, but I think in the beginning it's good to kind of write these out just so you make sure you're writing everything out correctly. So like in this case, 60 is going to be my A, 45 is going to be my B. And if you wrote this backwards, if you did like 45 plus 60, that's fine. Again, your final answer might look a little different, but it should be equivalent. So let's go ahead and fill in everything we know here. So equals cosine of A, so that'll be 60, times cosine of B, which is 45. Oops, I should not have done minus plus there. We're definitely doing plus here, so this should be minus, my bad. So minus sine of A, which is 60, times sine of B, which is 45. Sort of squeeze that in there. So I can go ahead, I'm going to erase this just to kind of, so it's not so cluttered up here. Let's get rid of all that. Okay, so now I've got 1, 2, 3, 4 trig functions that I need to evaluate. This is where your unit circle is going to come in handy. You want to have that unit circle ready to go for us to actually evaluate all these. So let me pull out my unit circle. There we go. So cosine of 60, if we look at 60, is going to be, let's see here, cosine of 60 is going to be the x-coordinate at 60 degrees. So you can see that's going to be 1/2. Cosine of 45 is going to be root 2 over 2. So we're multiplying there. And then we're going to subtract sine of 60, which is root 3 over 2. This will be good, just basic unit circle practice too. Sine of 45 is also root 2 over 2. And then now we want to multiply and subtract here. So we multiply those together to get 1 times root 2 is root 2. You know what, I'm gonna give myself a little bit more space here. So 1 times root 2 is root 2. 2 times 2 is 4. Minus root 3 times root 2 is going to be root 6. 2 times 2 is 4. And luckily we've got a common denominator already, so we're just going to pull everything together, and we get root 2 minus root 6 all over 4. So there's number 1. So that's what cosine of 105 degrees equals. There's no real way to simplify this any further, so you just leave it like this. This is the exact value. If you work this out a little differently, like for instance, if you did something like 135 minus 30 and you use the difference formula, that's fine. Your answer might look a little different, but you might throw this in the calculator and just kind of see what it equals and see if they equal the same thing. So that's number 1, or 1A rather. So let's take a look at the next one. So the next one is sine of negative pi over 12. It's So this is one where, you know, what I was referring to earlier with the over 12s, it may be useful to have a list where you've already sort of converted everything to pi over 12s, just to find this combination a little bit easier, because if all you're doing is looking at these radian measures, every time you're sort of mentally computing whether or not it works, you've got to convert it anyway. So if you do that work up front, now it's a lot easier to find a combination that's going to add or subtract to negative pi over 12. Now, being that it's negative, I think it's kind of obvious that we're going to lean towards a subtraction here. So what we're looking for is any two of these angle measures that have a difference of pi over 12, and we want to subtract the bigger one from the smaller one. So, like for instance, here's a combo that'll work. Like if we have 3 pi over 12 minus 4 pi over 12, or pi over 4 minus pi over 3, that'll work. But we can see that there's some other options here. Like we could do 8 pi over 12 minus 9 pi over 12. We could do 9 pi over 12 minus 10 pi over 12. 14 pi over 12 minus. So there's a lot of different combinations that will get you there. And again, your final answer might look a little different than what I do, but just, you know, throw it in your calculator if you're not sure, and you can see whether or not you got that right. So I'm just going to pick like the first one that occurs here. I'm going to just look at these. Okay, so I'm going to do pi over 4 minus pi over 6. Okay, is that going to work? Wait a minute. Yeah, pi over 4 minus pi over 6. So, oh, no. Hold up. Yeah, that's, I knew something was wrong here. Pi over 4 minus pi over 6 is going to give me positive 1 pi over 12. I want it to be negative, so I really need to do pi over 6 minus pi over 4, right? Pi over 6 minus pi over 4. I could also do pi over 4 minus pi over 3. I think that's what the key has. So we'll just see if we get the same thing as the key. So let's go ahead and start this out. So I'm going to say this equals sine of this 2 pi over 12 minus 3 pi over 12. That's what's going to give me the negative 1 pi over 12. But I'm going to use these, okay, because when we go to evaluate, we're going to be more familiar with these angle measures anyway. So that's going to be pi over 6 minus pi over 4. And so now we can use the sine difference formula. So the sine difference formula is going to be this minus minus deal over here. So that's going to be sine of A, which is going to be pi over 6, times cosine of B, which is pi over 4, minus cosine of pi over 6 times sine of pi over 4. And so we'll go through, we'll evaluate each 4 of these and pull together like we did the last problem, and we'll be done with that. So let's go through this. So sine of pi over 6, I went ahead and left this unit circle up here for you guys, so we don't have to keep taking it down and putting it back up. But let's see here. So sine of pi over 6 is the y value. That's going to be 1/2 times cosine of pi over 4 is root 2 over 2. Cosine of pi over 6 is root 3 over 2. And I know I'm kind of evaluating these pretty quickly. If you're confused on where these numbers are coming from, they're coming from the unit circle, but hit me up in the meet or send me an email if you're just totally lost on how I'm coming up with these values, you know, or these ones over here. That's something that we worked on in the first couple units. So sine of pi over 4 is root 2 over 2. And so now I can pull it all together and get my final answer. So 1 times root 2 is going to be just root 2. So you get root 2 over 4, 2 times 2 is 4, minus root 6 over 4. And let's go ahead and pull that together. We've got a common denominator, so nothing to worry about there. Root 2 over, root 2 minus root 6 over 4. And so that's the value of sine of negative pi over 12. I think this is the same thing that we got in on the key. You know, so the key, instead of doing this, did sine of pi over 4 minus pi over 3, which is totally fine. That works. as like an alternate here, and if you work it out, you're actually going to get this exact same thing. So that's good. Okay, so that's 1b. Let's look at 1c, which is going to take on kind of a similar structure here in terms of how we solve it. We're dealing with a tangent function, and we're dealing with tangent of 11 pi over 12. So again, notice it's one of these over 12s. That's going to be very common, and so it's I'm going to keep referring back to this little list to help me find a combination of two angle measures that either add up to 11 pi over 12 or whose difference is 11 pi over 12. So like for instance, I could do like 8 pi over 12 plus 3 pi over 12. 8 plus 3 is 11. What else could we do here? Is that it? We could do, how else could we get to 11? Oh, we could do 15 pi over 12. So 15 minus 4 would give us 11. We could do 21 minus 10. And what did I say? 8 plus 3. So there's a couple of different ways we can get there. And I usually just stick to the smallest angles I can find. That's just a habit I have, so I can kind of stick to first and second quadrant if I need to. No real reason for that. I'm not getting any particular advantage. It's just kind of the way I've always worked these problems out. But you're more than welcome to find some other combination that works. So I'm going to go with the 8 plus 3, right? 8 pi over 12 plus 3 pi over 12. So that's going to be pi over 4 plus 2 pi over 3. So tangent of 11 pi over 12 is going to equal tangent of, what did I say, 2 pi over 3 plus pi over 4. So that's the 8 pi over 12 plus 3 pi over 12. And the tangent formula is looks a little tougher because we got this big fraction, but it's really not that much different. When we go to simplify, it might be a little trickier, but for the most part, we're still just plugging numbers in here. So let's go ahead and plug in those values. We're dealing with the sum formula for tangent. So this will be, let's see, tangent of A, so that'd be tangent of 2 pi over 3 plus tangent of pi over 4 all over, and the tangent one kind of usually takes up a little bit more room too. In fact, well, I'll just leave it like that for now. 1, and then this sign should be the opposite of this one. Notice on the formula you've got plus minus on top, which is the same as this plus minus over here, but on the bottom it's minus plus. So that means if I'm going with the top symbol here and I'm going with the sum formula, this should be plus, plus, minus. By the way, you don't need to memorize these, okay? Don't waste your time trying to memorize these. If you use them enough, you'll become familiar enough with them that you might memorize them on accident, but there's no requirement to memorize them or anything. So let's see here. We get 1 minus tangent of 2 pi over 3 times tangent of pi over 4. And now we're going to start using our unit circle here. So I'm going to give myself a little bit more room here. Big old fraction. We got the 1. Okay, so tangent of 2 pi over 3. I'm going to look at 2 pi over 3. And remember that tangent is y over x. So if at tangent, so at 2 pi over 3, you're looking at this unit circle over here, the y is root 3 over 2, and the x, just doing a little scratch work here, is negative 1 over 2. Whenever you're doing these tangent ones, these over 2's will always pretty much cancel out, so you really just need to look at the numerators. Root 3 over negative 1 is going to be negative root 3. So what we get here is negative root 3, okay, for this tangent of 2 pi over 3. Then tangent of pi over 4, love doing tangent of pi over 4s, 3 pi over 4, all those, because if you look at those coordinates, x and y are always the same or they're opposites. So that's always going to be 1 or negative 1, which is really convenient. So love it whenever that happens. Tangent of pi over 4 specifically is just 1. So we get plus 1. And then we have 1 minus tangent of 2 pi over 3. So I'm looking back at 2 pi over 3. We've already evaluated that, right? So we don't need to do that again. It's just going to be, I'm going to put it in parentheses at first, but you'll see we might need to simplify that. But we get negative root 3 times tangent of pi over 4. We already did that as 1. So let's go ahead and simplify this. So this one will work out pretty nicely. So we have this, you know, I usually like having the minus. It doesn't really matter this order here, but I kind of like writing it like this, 1 minus root 3. It's just one less symbol to write, but if you leave it like this, that's totally fine. And then on the denominator, we have this, you know, times 1 doesn't really change anything, so we're just sort of going to ignore that. And then we've got minus a negative root 3, so that's going to be plus root 3. Don't worry about trying to rationalize this denominator or anything like that. You can just leave it like that. That's totally fine. All right, let's take a look at D. So what do we got D here? We got cosine of 17 pi over 12. So I'm looking for a combination of angle measures that add up to 17 pi over 12. I'm going to break out this list again. I'm trying to get to 17 pi over 12, okay? So I could do something like, I guess the quickest one would be like 2 plus 15 would work. I could also do 3 plus 14. I could do, is there 13? No, that's not going to work. So I could do 6. There's no 11 here, so it's not, nothing there. But I could do like 8 plus 9. That would work too. So a lot of different combinations here. I think on the key, we had the 2 pi over 3 plus 3 pi over 4, so we got this 8 plus 9. So I'm going to try something different just to see if the answer looks any different, kind of showcase that. But so let's see. I'm going to go with 2 plus 15. So that's pi over 6 plus 5 pi over 4. Pi over 6 plus, what did I say? 2 plus 15 would be 5 pi over 4. And so now we're going to use the cosine sum formula. We already did that once on the last page for part A. You know, this formula right here, we're doing the sum formula, so this is plus, and then this symbol in the minus in the middle here should be minus. So we've got cosine of A, which is pi over 6, times cosine of 5 pi over 4, minus sine of pi over 6 times sine of 5 pi over 4. Okay, so now we're just going to use our unit circle to evaluate all that. Cosine of pi over 6 is root 3 over 2. Cosine of 5 pi over 4, that's in quadrant 3. That's negative root 2 over 2. So this term is going to be negative when we simplify that. Minus sine of pi over 6 is 1/2. And sine of 5 pi over 4 is also going to be root 2 over 2. So, I'm sorry, negative root 2 over 2. Okay, so let's start simplifying some of this stuff. So we get root 3 times negative root 2 is going to be negative root 6 over 4. And then we've got 1 times, okay, so we've got minus a negative here, so that's going to be plus root 2 over 4. Again, we're subtracting a negative. 1 times negative root 2 is going to be negative root 2, so minus a negative is the same thing as adding. And then to pull all this together, we've got negative root 6 plus root 2 over 4. And I believe that is what we had on the key. These might have been flipped. In fact, I kind of like it better like that, but you know, it's just one less symbol to write. But either one of these is fine. These are equivalent. All right, this video is starting to get a little long, so I'm just going to finish. I'm going to do E and F, just the front page, and then I'll have the back page on a separate video. Okay, so E would be sine of negative 15. So I'm looking for, now it's a negative, so I'm probably going to want to find a difference of these angles that where the difference is negative 15. So this one's pretty straightforward. I mean, this one's pretty simple. I would do 30 minus 45. So this would be sine of 30 minus 45. Again, there's a lot of other combinations that could work too. This is just the simplest one, or maybe not even the simplest one, but just the first one that I found. So let's see here. We have sine of 30 times cosine of 45. And I'm going to be straight up with you. I don't have these memorized. I'm looking at this formula every single time I do these problems because I don't want to make a mistake. I mean, look at, there's so many sines and cosines and pluses and minuses. It's too much to memorize. And let's be honest here, there's no reason to memorize these. As long as you understand the concept, the smarter choice would be to look it up every time to make sure you don't make an error. And so that's what I do every time. I just have this like right next to me, and I'll just put it right here, and so I'm just kind of copying it over and making sure that I don't make any mistakes. Okay, so minus cosine of A would be 30, and then times sine of B would be 45. Same thing with the unit circle. You know, if I had a paper unit circle, I'd have it next to me too. Luckily, I've got, let's see, this unit circle right there. So I just look at that. All right, so sine of 30, let's see, sine is going to be the y value at 30 degrees, so that's going to be 1/2. 1/2 times cosine of 45 is root 2 over 2 minus cosine of 30 would be root 3 over 2, and then sine of 45 is root 2 over 2. Honestly, like once you start doing like, 5 to 10 of these, after you get like a good number of practice under your belt, you're going to notice these problems go way faster because not only are you getting used to like these formulas, but you're also going to start getting back in the hang of evaluating these a lot faster. So you'll notice that as we go through and do a bunch of these, even I will just start to naturally move along at a quicker rate. Unless I start like talking about it or something, but like just when you get back in the habit of just constantly bouncing back and forth between the unit circle, you'll see that these numbers will come a lot easier for you the more you do them. Okay, so let's see here. So we got root 2 over 4 minus root 6 over 4. So that would be root 2 minus root 6 over 4. Don't be tempted to subtract these. You can multiply roots like that, where it just sort of works out the way you would think it would. Root 3 times root 2 is root 6. But addition and subtraction doesn't work like that. So you leave them separate unless they have the same number underneath here. It's sort of like combining like terms. Okay, so there's E. And we'll just do one last problem on this video. Like I said, this is already getting close to 30 minutes here, so we'll wrap up the front page of the practice, and I'll do the second page on the next video. Tangent of 105. All right, so we actually, if we go back to the very first problem we did here, we already found a combination that will work for 105. Let's stick with it. You could do another one for sure, but I'm going to go with 60 plus 45. So I'm going to use the sum formula for tangent, and I'll just kind of bring that back over here. The sum formula here is going to be, A plus B. So I'm going to use the top symbol here. So I'm going to have plus on top, minus on the bottom. So this will equal tangent of 60 plus tangent of 45 over 1 minus tangent of 60 times tangent of 45. All right, so let's go ahead and evaluate these. Tangent of 60 degrees is going to be root 3. Tangent of 45 is just going to be 1. So kind of a similar, looks like this is going to look very similar to our last tangent problem. And then we've got 1 minus tangent of 60, which we said was root 3, and then tangent of 45 we said was 1. So So this one is basically done here. Not much we could do to simplify the top. Really the only thing to do to simplify the bottom is to multiply that by 1. And there you go. All right, so I'm going to wrap up this video. I'll provide a link in the description for the next one so that you can find it easily, or you can just find the next one on Schoology. So that's it, and I'll see you in the next video.